I'm going to talk about data engineering using speech commands as a specific example. In the previous video, what we learned about was that data engineering is a crucial process and that there are a set of steps that we have to execute. And I introduced each of those steps in abstract terms as general concepts. What I want to do now is actually ground that. I want to talk about speech commands in each of those different buckets. So recall that speech commands is a data set that Pete Warren put together in 2018. Now, this data set pretty much had to go through these fundamental steps. Any data set goes through these steps. And you've got a set of requirements that motivate, you kind of have to build, why are you building this data set? Then you have to figure out how you're actually going to gather the data. And then you have to clean the data, and then you have to continue to start to improve that data. So let's go through each and every single of these steps. Let's talk about what actually motivated him to build this data set. First and foremost, keyword spotting was just starting to take off back in 2017, 2018. But the problem that it had was that it was just limited to big organizations. There was nothing out in the public that you or I could use, be it for research, for education, or for commercial purposes. There was no public data set. So that was a seed that kind of jump-started the whole process. And there were, bigger speech data sets like library speech and so forth, but they were not focused on keyword spotting, which is the critical requirement here. Recall that keyword spotting is specifically looking at one word, not a whole spoken sentence. Also, while Google, Amazon, and Apple were putting out products that, quote unquote, had this keyword spotting capability, they were all using proprietary data sets because they have the ability to build those private data sets by hiring people to actually get the data that they need. But there was nothing out there for the public good. And that's what Pete was going after and trying to build a public data set. And so the goals were to make sure that the data being collected was in such a way that it was actually permissible for distribution, be it for research, education, or commercial purposes. And so there are some of the fundamental requirements over here, right? So ultimately, if you want to get these fundamental requirements, a data set has to become, can then become a new standard. So speech commands today is effectively the de facto standard for keyword spotting applications. And we'll see how that's actually affected how we do things. So what were some of the additional requirements that Pete had identified in terms of what needs to go into the data set? This fundamentally ties down to what are the common keyword application use cases, right? Yes, no, as an example. That's a very common because you might get a machine asking you a question and you want to say yes or no. For robotics, for instance, if you want to control some kind of autonomous vehicle, well, typical commands are usually left, right, go, stop. Or for numbers, maybe you are on a telephone and you often say digits, like your credit card number or your social security number. The machine responds. So that's keys, the key to keyword spotting data sets, for instance. So you go from 0, 1, 2, 3, 4 to 9, and those are the requirements. So the next step is, how do you actually go about gathering the data? What are the sources? Who are the people who contributed? And how do you get the data labeled? Well, that was built on the backs of people. People contributed their own time and effort. So over 2,600 volunteers consented to have their voices recorded and distributed. They consented. And that was part of the licensing thing. They understood why or what Pete was doing and agreed to have their data be shared. So therefore, we have this access to this data today. And because people were contributing, we naturally had a variety of different, accents being captured in that data set. And remember, we need to have a large number of samples. So there were over 1,000 samples for each keyword in there. And obviously, some words are more popular than the others, but that's okay because it really depends on what your application is going to be. And that's why I was saying earlier that you need to make sure that you know what your application task is, because that means that you need to have the right data set at hand. And therefore, you need to know the characteristics of the data that's inside of this data set. In order to make it accessible and in order to be able to collect it very easily, it was simply set up in a web browser. Basically, that was a URL that you could open up in your browser and you would be able to record your voice and contribute. Nothing else was needed. No apps were installed, nothing custom. It was just a website. Next, after getting all this data, we said we have to refine the data. And how do we go about doing that? So some data is simply not useful, right? So we talked about ideas of like looking at audio signals and saying that they were too quiet so that you can't really extract useful spectrograms from them. Maybe instead of saying yes, someone was messing around and saying the opposite word for everything. Instead of yes, they were saying no. Instead of no, they were saying yes. People like to have a bit of fun. Now, you can do some of these things through automation. For example, you can check the volume of a particular clip and then be able to remove it automatically or normalize the volume so the volume is kind of normalized across the data set. You have methods to do that. You also need to be able to effectively identify the critical part of the entire recording, because when someone says record, it just starts recording until they stop recording. So you might have a 10-second clip that needs to be cut down just to the critical piece that is, actually has the keywords in it. Then someone, of course, has to manually validate that data set. You've got to go over 100,000 of these utterances that need to be manually validated. And that was, again, done through crowdsourcing, which effectively means that people volunteer to actually do the validation. And the final part comes down to sustaining or improving this data set to making it more accessible. So the original data set only had about 10 keywords in it. And now the data set is over 35 different keywords in it. And so it's starting to expand as this is effectively the standard that everybody is using to build keyword spotting models on. And so as the needs become more and more, the data set naturally continues to grow. And now the next thing is about having scripts that automatically do the training and validation test splits. Remember, I said earlier that when you are doing these splits, they're not arbitrary test splits. So the distribution of the data between, let's say, the training set and the test set needs to be thought through quite carefully. It's not some random sampling of the data. So there are scripts that actually do this. And so keep that in mind when you're building your data sets in the future. And of course, there's the ultimate question of how do you expand these to new languages, right? Speech commands is only focused on English. What's your language? My native language is actually Sindhi. I also speak another language called Hindi, and another language I speak a little bit of is Kannada. None of those keyword spotting are in the keyword spotting data set, which I really wish that we had access to. There are other things that are coming up in order to try and fill this gap, this niche. We need the need for new languages and keyword spotting. And we'll talk about that in the coming couple of videos. And you'll be very excited to see how you can potentially build the next major data set, of your language. Specifically, we want to be able to compare now different models that are being trained. But the models, they need to be working off the same standard data set. So speech commands is that standard data set. And so we can actually compare two different models and see which one is actually performing better. And it becomes basically a benchmark, right? Benchmarks are crucial because TinyML has very strong constraints, remember. So you want to be able to use the same data set to benchmark different systems. So we can actually assess the forward progress you're making, not just from the model accuracy standpoint, but also from the overall system efficiency standpoint, because now you're running this TinyML model that has been trained on the exact data that and then you're running it on a system. So you can also benchmark the system if you have a standard data set. And finally, there's a process of being able to improve on the data set that we started off. So speech commands is this original standard, and now we can continue to build on top of it. The key thing that I'm trying to get to do over here is that if you want to be able to move the needle forward, if you want to be able to enable TinyML in the future, we need to be able to do an apples to apples comparison from the data set perspective, because data sets are the rocket fuel for machine learning models. So we want to be able to make sure that we have a standard data set. And if we have a standard data set and people are building models, then we can also use that coupling to the benchmark different systems.